All right, this is 6.4, 292. Arguably one of the most useful formulas in your high school career as mathematicians. Okay, the quadratic formula. We just heard earlier what it does for us is it actually determines the roots of a quadratic. So quadratic formula, it's a formula for determining the roots of a quadratic equation of the form ax squared plus bx plus c. So a little clarification here. So when we're talking about determining the roots, so when we say the roots, what are we talking about here more accurately? Mark, when I talk about the roots, what am I talking about?
The X-intercept.
Good. The X-intercepts is probably the best synonym because it tells you exactly kind of what we're talking about here. So it's the x values when y is 0, right? So it's these things. Okay? We also use a couple other words to express the roots, or to synonyms for the roots. What are they? Yeah, Matthew?
Zeros.
Okay, yeah, they also call them the zeros because they're when the y value is 0. Anything else? Lucas, do you remember another one? No? Steve?
Solution.
Good. They call them the solutions because they solve the equation. So in other words, when we have that x value, the equation is true. That's why they call them the solutions. Okay? So the roots can be called the x-intercepts, the zeros, or the solutions. Alright? Of a quadratic equation of the form ax squared plus bx plus c. This is very important, alright? You cannot use the quadratic equation unless your formula is set up this way. Okay? You can't even start to use this unless you have it set up this way. And what way is this? What is this called? Let's try someone else. Ace. What's this called? What format is that called? What form? So there's vertex form, there's factored form, and then there's this. Which is called, yeah, good, standard form. And Ace, what are some of the advantages of standard form? Okay, yeah, you could do that. But some of the advantages are, why do we like standard form? All right.
Tells you the y-intercept?
Right, it tells you the y-intercept for one. And the other big one is that it allows us to convert not only to factored form, but also to vertex form. Okay, that's the reason why. You got to go back to standard form before you can factor. You got to go back to standard form before you can complete the square. Okay, so let's now do an example of completing a square, right? So we're going to do, just as a refresher, try and fit this neatly in here. We'll put this a bit higher. Okay, so when we go to complete the square, who can tell me the first step? This is going to be on your quiz tomorrow, guys. Joshua, what's the first step? What do we got to do?
You remove the a value of x.
Good, excellent.
Beside x.
We don't remove it, but we factor it out, right? And how many terms are you going to factor it out of?
You partial factor.
Good. Yeah, partial factor out of just the first two terms. So dividing the first term by 2, we get 2x squared. What about this one? What are we going to get? Plus
5 over 2x.
Excellent. 5 over 2x. Now what do we do?
You close the brackets and you put plus 1 on each side.
No, not yet. We're completing the square. Try someone else. Henry?
Do half of 5.2, or 5 over 2, sorry.
Right, so just do a little side here. Half of 5 over 2. So 5 over 2 divided by 2 is the same thing as 5 over 2 times 1 over 2. Okay, because when we divide by fractions, we actually multiply by the reciprocal, right? So this is equal to 5 over 4. Okay, does everyone get that? All right, so we're going to add 5 over 4 all squared. And, okay, next.
Then subtract 5 over 5.
Good. So then we're going to subtract 5 over 4 all squared. Excellent. Now what?
Close the bracket and put
Excellent.
+1.
Okay, good. All right. Any questions up till there? No. Okay. So we're going to move on. The next step is we want to create our perfect square trinomial. Okay, so we need to eliminate this last term here. So in order to do that, we're going to leave everything as is, the first 3 terms. But we want to close that bracket now, multiply this by 2. So it's going to be 2 times negative 5 over 4 squared. So that's going to be negative 2 times 5 over 4 squared. We'll do a little side here. 5 over 4 squared is going to be 25 over 16. Remember, this square applies both to the numerator and the denominator. So this 5 over 4 becomes 25 over 16. And then we have negative 2 times 25 over 16. Negative 2 is over 1. So we get negative 50 over 16. Okay? Any questions there? All right, so then, yep. Oh, sorry, positive 2, yeah, but it's negative 5 over 4. So positive 2 times negative. Okay? Same thing. So we end up with negative 50 over 16 plus 1. Next step. Kyle, what's next?
You add like negative 50 over 16 plus 1.
Okay, we'll do that at the end. We can do something here first. Is it a perfect square trinomial?
Yeah.
Okay, so what can we simplify this to? Leave the 2, right? And now?
X plus 5 over 2.
No, plus 5 over 4, right? The square root of the n term.
Over 4 squared.
Good. And then minus 50 over 16 plus 16 over 16. Okay, just converting the 1 to 16 over 16. Any questions? No? All right, moving on. 2x plus 5 over 4 squared. Now we're going to have 16 plus 50, so that's going to be 34. And 34 divided by 16 is not quite an even number. Okay, but we're done completing the square there.
So it would be 17 over 8.
Yeah, you could divide by 2. Yeah, you can write that to 17 over 8, sure. All right, so the last thing we want to do, because we've set this whole example equal to 0, see from the beginning, this is all equal to 0, equal to 0, equal to 0, equal to 0. The last thing we want to do is now solve for the x values when y is 0. Okay, so in order to do that, we just need to rearrange this equation, right? So we're going to move the negative 17 over 8 to the other side. So that's going to be 2x plus 5 over 4 squared is equal to positive 17 over 8. Okay, everyone see that? Now I want to divide both sides by 2, so I'm trying to isolate this x value. So we have x plus 5 over 4 squared is equal to 17. Now, divided by 2 is the same thing as multiplying by 1/2. All right, so we're going to have 17 over 16. Any questions there, that part? No? All right, so the next step now, we want to square root both sides because we want to find out what x is. So in order to get x by itself, we have to take the square root of both sides. Okay, that'll leave x plus 5 over 4 is equal to, now when we take the square root, we have to consider both positive and negative. Because if you multiply a negative times itself twice, you're going to get the positive value. So you're going to have plus or minus the square root of 17 over the square root of 16. Okay, once we do that, we have x plus 5 over 4. Let's make this small. Is equal to plus or minus the square root of 17 over square root of 16 is 4. Now we're going to have x is equal to, moving the 5 over 4 to the other side, plus or minus the square root of 17 over 4 minus 5 over 4. Because you have a common denominator here, we can combine these two terms. So we have x is equal to plus or minus the square root of 17 minus 5 over 4. And now you just want to rearrange this so that the negative 5 is before the plus or minus, just so it looks a little neater. So I'm just moving that 5 in front. X is equal to negative 5 plus or minus square root 17 over 4. All right, so having done this then, now I solved, when I set y equal to 0, I solved for x. So this value of x now is telling me the x-intercepts because I set the y value equal to 0. Any questions about this? Seems long and a little cumbersome, and it will be the only time we do this, okay, because we're just proving it, yeah?
You see that it shows both intercepts?
Yeah, because there's two answers here, right? There's negative 5 plus root 17 over 4, and the other scenario is negative 5 minus 17 over 4. So this equation, this plus or minus, is actually incorporating two full values, different values of x, okay? All right, so now let's see it with variables. We're going to try that again. So this time, we have ax squared plus bx plus c is equal to 0. So if we can complete the square with these variables and solve for x in terms of the variables, then we'll have a generic formula for any values of a, b, and c. Okay, so this is how we're going to derive the quadratic formula. So I'm going to go take the same steps. So the first thing I want to do is divide all the terms by a to remove a from our first term, right? So a x squared plus b over a x. Okay, we're removing a from the first two terms. Now I'm going to add half of this value squared, so plus b over 2a squared minus b over 2a squared. Okay? It's the same steps. Close my brackets, plus c, it's all equal to 0. Once I do that, now I want to create this perfect square trinomial, so I'm going to keep the first three terms. This last term I want to multiply by a, so it becomes negative a times now I have a perfect square trinomial, so I'm going to factor that. This drops down, this is that. So I'm going to distribute this square, so I can combine the a. So this square I'm going to apply both to the numerator and the denominator, so I get b squared over 4a squared and then plus, I want to have a common denominator, so I want to multiply c times 4a squared on both the numerator and the denominator. So I'm going to get 4a squared times c over 4a squared. You see what I did there? I just multiplied the c times 1, but to create a common denominator. And all this is equal to 0. Now these two terms can combine, so I'm going to have ab squared plus 4a squared c over 4a squared. So now I'm going to move this whole term to the other side because I'm trying to isolate for x. This is going to be positive, so ab squared plus 4a squared c all over 4a squared. You can see here a is common in both the numerator and the denominator, so I can divide 1a out. Actually, I can divide both sides by a. Took it out earlier. Okay, so what I did there was I just divided that a square out of the numerator. So it disappeared on the left-hand side and disappeared on the right-hand side. So one a term got reduced. Now I want to take the square root so I can isolate for x. So it's going to be x plus b over 2 2a is equal to the square root of all this, square root of b squared minus 4ac, all over the square root of 4a squared is just 2a. Okay, square root of 4 is 2, square root of a squared is a. Alright, so we're getting close now. Remember, this is plus or minus. Have to consider both conditions. Now we have x equals going to move the b over 2a to the other side. So we have plus or minus square root of b squared minus 4ac all over 2a minus b over 2a. So now because these two terms have a common denominator here of 2a, I can combine the numerators. So I get x is equal to, I'm going to put the negative b first, minus b plus or minus square root of b squared minus 4ac all over 2a. Yeah?
When you factored out the a on both sides,
Yeah?
how come for the denominator you didn't take out to make it 4a, you left it at 4a squared?
Because I divided each by a. So the a would go over here, divided by a. So this a, that stays, and this a cancels.
So you only divided the numerators by a?
Yeah, I divided, yeah, the whole term is divided. When you divide a fraction, if you're dividing it by half, you are only just dividing, you know, the numerator. If you divide both sides, you're basically multiplying by 1.
Oh.
Okay? Okay. 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 Thank you. All right, so guys, I know it seems quite complex and quite complicated, But I can assure you, the completing the square, the process was the same. There was a little bit of tricky math in here, just trying to simplify things, but the process was the same. Okay, so if you take your time with it and go a little bit slower, I'm sure you could eventually get there as well. That's likely maybe something that you'd see as a bonus on the test. Okay, being able to prove that. That is your final equation though. Okay, that's your quadratic equation. Yeah?
So when you factor out the a, when you multiply it on the other side, instead of doing, so it was basically 1, dividing by half would be 1 over a, so then you did a over 1 times it and multiply it.
Which one is that?
Yeah, right there.
Here? Here to here?
Yeah.
Okay, you've been dividing both sides by a.
So it would be a over 1 instead of 1 over a.
A over 1.
To divide. You have to do the reciprocal. Is that 1?
No, so it's like multiplying this by 1 over a. And multiplying this by 1 over a. So the a's cancel here. And then this would become 4a cubed, but because there's an a common here, it comes out of the numerator.
Oh.
Okay? You could have actually factored this a out up here. Okay, it might have been simpler to take the a out originally. Alright? Okay, because you can see the a is all common here. And a in the numerator, a in the numerator, a in the numerator. Alright? Alright, any questions? That's our final equation. So now if we have this equation, and you have your equation set up in standard form, it's just a matter of plugging in values and solving. So we don't have to go through M&A anymore. So we have 2x squared, let's say plus 9x plus 6 is equal to 0. So now, because this is in standard form, I know my a value of this is what, Luigi? What's the value of a for this?
2.
Good. So a is equal to 2, b is equal to?
9.
And c is equal to? 6. Okay, so we know a, b, and c. We could just plug it into this formula now. So x is equal to, plugging in for b, so it's negative, now I plug in b is 9, plus or minus square root of 9 squared, minus 4 times a is 2, times c is 6. Okay? Biggest mistake people make with this equation is they just put the square root over 2a. Okay, that's not right. The whole term is over 2a. Okay, it comes into play at the end as you solve for x. So make sure that you have the whole term, including the b, negative b over 2a. So 2a, so 2 times 2, right? Okay, now you can just solve using your calculator, most of you, plus or minus square root of 81 minus 4 times 6 is 24 times 2 is 48, so minus 48 all over 4. Okay, remember this is x, these are your x values. So next step, x is going to be equal to negative 9 plus or minus 81 minus 48 is 33.
35.
Oh, 35?
No.
33, no?
Yeah.
31 minus 48.
Plus or minus 33 all over 4. Okay? So guys, when you get to this point, there's nothing more you can simplify, so you need to break the answer into 2. Alright, so it breaks up into 2 answers. Alright, and what they are is one is with positive and one is with negative. So one would be x is equal to negative 9 plus the square root of 33 over 4, which is equal to this, and then the other one is x is equal to negative 9 minus the square root of 33 over 4. Okay? So now you work those answers out. And you get a negative 0.81 and negative 3.69. Okay, so these then are our x-intercepts. So you didn't have to do M&A, you didn't have to factor, You went directly from standard form, plugged it into the formula, and you got two values of x. Okay, and the beauty about the quadratic equation is that these values don't have to be factorable over the integers. They can also be decimal values or fractions. Okay, as long as you have it set up in this order, A, B, C, you can use any numbers and just plug it in. Okay, we'll take a significant amount of practice being comfortable with the equation. Remember, if B is negative, then this becomes a positive, right? Because it's negative, negative. Okay, so if A is negative 9, this would have been positive 9 here. Okay, also be careful when you square. If this is negative, it's always going to get squared. You actually square the full number, so it wouldn't be negative in this case, that first term. All right, let's show one more example with some negative signs. Okay, yeah, I'll show you guys one more. Yep. Ready? Yep, go ahead. Okay, what's the first step we do here? Who can tell me? What's the problem with the way this is? It's written. Yeah, it's not in standard form, so how do we fix it, Alan? How do we fix it, make it into standard form? Come on, you know how to change this into standard form, right? Not sure? Andrew?
We bring the 9 over to the other side?
Yeah, you just move this over, right, Alan? You remember this? So you're left with plus 9 equals 0. Okay? Do you understand that? Alright, so now it's in standard form. So my value of A, Dominic, is what?
4.
Good. B?
12.
Not 12, but
9.
no.
Negative 12, sorry.
Negative 12. And C?
9.
Good. Okay, so we have A, B, and C. We're going to use our formula. You guys, by the way, have to memorize this formula, okay? It's not going to be given to you on the exam. Make sure that line extends over the negative B. It's all over 2A. Okay, so that's our formula. We just go ahead and plug in. So B is negative 12 here, so pay close attention. It's negative 12. Yeah, so it would just be positive 12 in that case, plus or minus. And then, like how we did before when we were minusing the number, when we completed the square, I was showing you it was like negative 12 squared, for instance. This would still be a negative number. In this case, it's not, okay, because you're actually subbing in the value right in to that B term. I'm not an eraser, but. So in this case, the negative 12, it's the square root of, in brackets, negative 12 squared. Okay, make sure that you realize that this is going to be a positive number now. If you mess up anywhere in this equation, you're going to get the answer wrong.
So why is it in brackets?
Because you're subbing in the value of negative 12 fully in for B. Okay? It's not like when we added a number and subtracted a number. That number that we subtracted had to be negative, right? Even though it was squared. In this case, you're subbing in for B, so it's that value squared. Okay, so it becomes positive. So minus 4, and then A, you're going to sub right in as 4, and B, sorry, C is 9. All over 2 times A. So we get positive 12 plus or minus square root of 144 minus 16 times 9. Sorry? 144 again, all over 8. So this is interesting. We end up getting 12 plus or minus 0, right? All over 8. So finally, our final answer then would be
3 over 2.
3 over 2. So anybody have any idea what that means? There's only one x-intercept. So if we think about that on our graph, we're saying x is equal to 1.5, right? 3 over 2. What does that mean? Any idea? So 3 guys that are thinking about this. 4 guys. 5. Anyone else? There's one x-intercept. So what could it mean? Yeah, I'll read.
Problems looking towards the right, so it's like that.
No. No, you never see a problem like that. It's not a function. Gianluca.
It's the vertex.
Good, yeah, it's the vertex, and we know it opens up, so we know it's like this. Excellent. So I'm glad you guys are thinking, right? You're understanding what goes on the graph. Okay? So it means there's only one x value. Because this is 0, there's only one x value when y is 0. And that means it's the vertex. Okay? Because if we add this plus another x-intercept, divide by 2, it's going to only be the 1. You can't add them together. Okay? So that's the vertex. What if we had a graph that looks like this? Okay, this is now the parabola that we're concerned with. What's the x-intercepts for this, Daniel?
There's only one.
Is there? There's an x-intercept?
Oh, no, 0, but.
Is there an x-intercept here?
No.
Does it hit the x-axis? No. Will it ever hit the x-axis?
No.
No, it never will. So in a graph like this, if you can imagine this, the square root value is going to be what? 0, positive, or negative? Nicholas, what do you think? It's got a 33% chance of getting it right. Square root value, 0, positive, or negative? 0? No, that was this case, okay? We showed that, right? We saw that already? Yeah?
Positive.
Positive. No, if it's positive, then we have a value here that we can square root, right?
Wait, negative.
So yeah, the answer is, I guess the third one is negative, right?
Oh my god.
And the reason why, guys, the reason why is because a negative square root is undefined, right? We can't multiply any number times itself and get a negative value. Because a negative times a negative is positive, and a positive times a positive is positive. So if we get a negative square root value, then our graph is something like this. Be careful though, more likely than not, when you guys are starting this, if you get a negative value in the square root, you've done something wrong here. Okay? But just to be clear, it's possible that you get a negative value, and the answer for x then is no solution. There are no x-intercepts. Okay, any questions about that? Alright, you can end the video. That's